Welcome back to part 16 of our DIY Autonomous Mobile Robot Building series. Today in part 16 we'll finalize the neck structure. We'll also use the emboss tool to create precise openings. If you're just joining us, be sure to check out parts 1 through 15. The links are in the description and the full playlist is at the end of this video. Okay, so we might start off by relabeling some of the components because their names might not be so accurate anymore after a number of combining operations. For example, when we hide the component labeled neck base, the entire lower body disappears, so that label will need changing. Also, when we unhide body shell, nothing happens because now only the head and neck components are stored under body shell. Let's unhide the head, the neck, and the neck tube. Click on body shell and rename this group of components to head and neck. We'll just hide the head and neck for now and unhide the component that is labeled neck base. And let's just rename that to lower body. Here the footage shows a longitudinal section analysis where we can see that the neck base is integrally formed with the lower body shell. Unhide the SG90 micro servo and we can see that the SG90 fits nicely within the neck base. Unhide the plastic bushing that is on top of the SG90 servo horn and a few other components like the SG90 base and the battery pack rear hooks 1 and 3. And let's also unhide the head and neck. I'll just hide the section analysis, hide the lower body shell. Now that's the configuration we have at the moment, but it looks as though the neck tube needs to be changed as the servo horn of the SG90 micro servo penetrates through it. Let's hide battery pack rear hook 3, hide the SG90 base, hide the SG90 micro servo, and hide the battery pack rear hook 1. Let's also hide the plastic bushing. The neck tube doesn't seem to be the right diameter or the length for our needs, so I decided to get rid of it. So let's create a new component and label it cylinder tool. Create a new sketch with cylinder tool activated. Select the plane here for the new sketch. Select the circle tool and create a 25mm circle. So as you can see, this circular plane is positioned at the origin relative to the Z direction as well. Extrude by 20mm and activate the main design at the top of the browser. Turn on the section analysis, select cylinder tool on the browser, and then select the move copy tool to move the cylinder tool upward right into the neck area. Before we conduct a cutting operation, let's open up the cylinder tool folder and then the bodies folder. Let's also open up the folders for the head and neck component. As it turns out, we'll not be needing the neck tube, so let's right click and select remove. Next, select the combine tool, select capture position, and for the target body, select the neck body in the head and neck component in the browser, and for the tool body, select body 1 under cylinder tool folder in the browser. As you can see in the combine palette, the operation is already set to the cut operation. So hit OK to complete the cutting operation. Unhide the plastic bushing. As you can see, the plastic bushing interferes with the head body, so we'll need to do something about that. Here the footage has jumped ahead a bit with the lower body unhidden, as well as the SG90 micro servo. I'll just take this opportunity to remove the cylinder tool by right-clicking and selecting remove. This component here, labeled component by default, was used as a tool at some stage, but now is safe to remove, so let's right-click and select remove. I decided to use a plastic bottle cap to house the plastic bushing while also providing some protection for the wiring. Check the link at the end of this video to see how I created this bottle cap. Also, a step file of this bottle cap can be accessed and downloaded on my GrabCAD account. Check the link in the description to access that file. So here we have the plastic bottle cap, which I created within this robot design rather than inserting it. Let's unisolate it and activate the main design. Unhide the section analysis to confirm the positional relationship between the bottle cap and the surrounding components. Zoom up and there we can see two issues. One issue is that the neck flange is interfering with the bottle cap because the hole isn't quite large enough, and the vertical position of the plastic bushing is too low because it is still sitting on top of the SG90 micro servo horn. Scroll down in the browser until you see the plastic bushing, then click to select it. Go up to the toolbar and click the Move copy tool. Move the plastic bushing upward by 0.85 millimeters, which is the thickness of the plastic bottle cap. Now let's hide the section analysis. Scroll down to the lower body in the browser, right-click on it, and isolate it. So there's the opening, which is a little too small for the plastic bottle cap to fit through. Let's shift to the top view. From the Create menu, select New Component, and just label the new component Cutting Tool. Select the top surface of the neck flange and create a new sketch. Select Capture Position before we carry on. Select the Circle tool and sketch a 31mm diameter circle, which is 1mm larger in diameter than the plastic bottle cap. Finish the sketch. Tilt the design a bit, select the entire area of the circle we've just sketched, select the Extrude tool and change the direction on the extrude palette to symmetric. Since we'll be cutting in both directions, let's unhide the head and neck component as well. Let's move to the side elevation for better visibility. Here the footage has skipped a little bit where I have activated the entire design and I have changed the operation to cut on the extrude palette. I set the distance to 50mm, which was a bit excessive because it was set to 50mm in each direction, but the cutting tool is not interfering with anything else, so let's just hit OK. Hide the head and neck component and let's have a look at the hole. I think you can tell that it is larger than before. Let's unhide the head and neck and hide the lower body. That's the hole in the neck. Actually, the hole is probably the best part about the neck, so let's redo it. First, let's remove the cutting tool as we won't need that anymore. Hide the neck body, which is thankfully still a separate body. Tilt the head and we can see a nice opening there. Actually, I forgot to activate the head and neck component, so let's do that. Let's click on the canvas, hit bottom on the view cube, create a new sketch and select the XY plane. Press P to project and I zoomed up to the upper edge of the circular opening and selected it. However, since we're on the XY plane, the lower edge of the circular opening would have been fine too. Hit OK and let's go back to the bottom view and zoom out. Select the circle tool and sketch a 35mm diameter circle. Sketch another circle at a diameter of 31.5mm. Finish the sketch. Now hide the head body. Let's select the extrude tool first. Unhide the head and just reposition it like this. And let's initially extrude up by 15mm. Unhide the sketch we've just created. Select the fillet tool, select the outer lower circular edge of the cylinder we created and set the fillet to 2mm. So a 2mm fillet makes the rounded edge arrive at the projected 31mm diameter circle, not the 31.5mm diameter circle we sketched. I ended up not wanting a tighter curve than that, so I went with the 2mm fillet rather than a smaller one. Let's name this body upper neck, unhide the lower body. The upper neck is currently positioned at the origin, so select the Move Copy tool and move it up to the head. Okay, it looks as though the height of the upper neck is too tall, so hit OK and go to the timeline and edit the extrude feature by right-clicking and selecting Edit Feature. Let's change the extrude distance to 11.5mm and hit OK. Select the upper neck in the browser and select the Move Copy tool. Move the upper neck up to the head and hit OK. Activate the main design. Let's scroll down the browser and unhide the bottle cap. Let's zoom in. At the moment there is no hole in the upper neck, but I think you should be able to tell that the bottle cap fits nicely within the 31mm diameter hole that will be formed. Hide the lower body, hide the bottle cap, and hide the head. We can also hide the sketch. Now from Create, create a new component and label it Cutting Tool. Select the top face of the upper neck component and create a new sketch. Zoom up a bit and press P to project. Select the entire circular face of the upper neck body and hit OK. Select the circle tool and sketch a 34mm diameter circle and finish the sketch. Hide the head and neck component. Select the area defined by the 34mm diameter circle we have just sketched. Select the extrude tool and extrude by -11mm, which is 0.5mm shorter than the height of the upper neck. Then go and select the lower circular edge and select the fillet tool. Create a fillet of 1.5mm. Let's extend and the top of the cutting tool. So select the extrude tool, select the top face and extrude by a further 5 millimeters. In the footage, I unhide the head and neck component, which is currently only the upper neck component, though it is the cutting tool that is currently activated. Swivel the cutting tool so that we can see the underside. Select the underside. Here the footage has jumped ahead a little with the cutting tool at the bottom view. Create a new sketch. Select the circle tool and sketch a 31mm diameter circle. Here the footage has jumped ahead a little again with the sketch finished but still showing the 31mm diameter circle. Select the underface, select the extrude tool, extrude the 31mm diameter circular area by 0.5 millimeters, and there we have a 0.5 millimeter thick circular protrusion. Hide the cutting tool for now. Scroll up to the top of the browser and activate the main design. Unhide the upper neck and unhide the head also. Now scroll up to the section analysis and unhide that too. As you can see, the upper neck is still completely solid, but the vertical position is fairly good. Select the combine tool. Here the footage has jumped ahead a little bit. In the combine palette, you can see that a target body and a tool body have been selected for a join operation. So the head is selected as the target body and the upper neck is selected as the tool body, or vice versa. Now scroll down to the cutting tool and unhide it. Select the combine tool again, select the head as the target body and select the cutting tool as the tool body. We also need to change the operation to cut. I can see that I have mistakenly extruded the 0.5 millimeter thick circular boss on the underface of the upper neck instead of the underface of the cutting tool. I think the easiest way to fix that problem is to first finish the cutting operation using the combine tool by hitting OK, and then go to the 0.5 millimeter thick circular boss, select it, select the move copy tool and move it up by 0.1 millimeters. Hit OK or press return and then select the combine tool again. Select the head, which is integral with the upper neck now, as the target body, and select the 0.5 millimeter thick circular body as the tool body. Hit OK and hide the section analysis. Swivel the design to see the underside, and there we can see a nicely formed upper neck, integral with the head and with a 31mm diameter hole at the bottom. Unhide the lower body and then unhide the bottle cap. Isolate the bottle cap, press A for appearance and color it white. If you download a bottle cap from my GrabCAD account, it will already be white. Unisolate the bottle cap to bring the head and neck and lower body back. Unhide the section analysis, and there we can see the bottle cap with sufficient clearance from the neck flange on the lower body and from the upper neck of the head and neck component. I think it was at this stage I realized that the direction of the servo horn shouldn't be in the forward to rear direction, but in the left to right direction, because we don't want the servo horn to interfere with the wires that are connected to the HC-SR04 ultrasonic sensor. So here the footage has jumped ahead a little with the section analysis switched off. Right click on the SG90 and isolate it. This SG90 has been downloaded from GrabCAD, so here I have opened the file for this component, separate from the file of the main design. Open up the joints folder. Please note that in the latest version of Fusion 360, the joints folder is now a subfolder inside a folder called relationships. This footage was taken before that update. Right click on Revolute and select Edit Joint. Enter 90 to adjust the angle of the servo horn to 90 degrees. Hit OK or hit return. Then go back to Revolute again, and this time right click on Animate Joint Relationships to check the movement range. There we can see the servo horn is rotating to the right by 90 degrees and to the left by 90 degrees and is positioned at the lateral position or left to right position when stopped. Close the SG90 file and return back to the main design. Now we have a warning saying that the reference is out of date, so we can just right click on the SG90 in the browser and select Get Latest Version, upon which Fusion 360 commences to update the SG90 in relation to the other components, which may take a while because we have created a large number of components in this design. Anyway, there we have the updated SG90 micro servo with the servo horn in the corrected position. Select the SG90 in the browser, right click and unisolate it. Go to section analysis And here we already have a left-right cross-section, so let's just unhide that. There we can see the servo horn in the left to right direction or lateral direction. Just ignore the screws there, as I will use a different size and type, which I will detail in a future video. Go to the section analysis again and switch to the front-rear cross-section, and obviously now we can only see the central portion of the servo horn from this cross-sectional direction. We can hide the section analysis now. We can safely remove the cutting tool that we used to form the upper neck portion. Anyway, select the front to rear section analysis, and here in the data panel we have an HC SR04 ultrasonic sensor which I downloaded from GrabCAD. You should be able to locate a good 3D design by searching HC SR04 in the library and selecting Fusion 360 under the software option. I think this is the one I downloaded a while back. Right click the downloaded HC SR04 file in the data panel and select Insert into Current Design. Move the HC SR04 up to the inside of the head component. Rotate it forward by 90 degrees. Play around with the position to find the most natural position for this component. Hit OK. Let's close the data panel. Somehow I've managed to insert two HC SR04 ultrasonic sensors, so I'll just remove one of them. I'll just adjust the position of the HC SR04 a little more. Let's rotate the design to the front view. The circle of the HC SR04, which gives the appearance of an eye, looks a little too low and too close to the beak. So let's move the HC SR04 up a little, and it looks about right. We need to work on the head, so let's activate the head and neck component. Before we carry on, let's remove the old version of the neck. So with the head and neck component activated, select a new sketch and select the YZ plane. Select Capture Position. Press P for Project. Project the vertical center line. Zoom in and select the cylindrical transducer on the right side of the HC SR04, which appears on the left side of the canvas, and then select the cylindrical transducer on the left side of the HC SR04, which appears on the right side of the canvas. Select Measure from Inspect and measure the diameter of one of the projected cylindrical transducers, and we get a diameter of 16 millimeters. Select the circle tool and sketch a 21 millimeter diameter circle at an arbitrary position on the canvas. Then drag the 21 millimeter diameter circle to approximately where the eye opening of the head should go. Let's change the diameter of the circle to 18 millimeters and see how that looks. Select the tangent tool and make the 18 millimeter diameter circle tangent to the 16 millimeter diameter projected circle. I experimented with different sized eye openings and I finalized on a diameter of 22 millimeters. Hide the head to get a better view of our sketch and also hide the HC SR04. Select the line tool, change the line type to construction and sketch a vertical construction line from the top of the projected center line. Let's give this vertical construction line a length of 24 millimeters. Select the dimension tool and set the distance between the center of the 22 millimeter diameter circle and the vertical construction line to 16 millimeters. Now the sketch is constrained. Now we can easily mirror this right eye opening to create a left eye opening by selecting the mirror tool, selecting the 22 millimeter diameter circle as an object, and selecting the vertical construction line as the mirror line. Finish the sketch. We can unhide the head now. The footage has jumped ahead with a new sketch 14 created, onto which the 22mm diameter circles have been projected. The really important thing to note here is that the plane on which sketch 14 lies has been offset forward from the center of the head so that it lies outside of the head. I would have used an offset plane from Construct to achieve this, but unfortunately I did not capture the footage for this operation. From Create, select Emboss. Select each area defined by the 22mm diameter circles. Then select Faces on the Emboss palette, and then select the surface of the head. The depth of the emboss is set to the default value of 2mm. Let's change that to minus 0.5mm, and also we need to make sure the effect is set to deboss. Hit OK, and there we have the two eye openings perfectly formed. Unhide the HC SR04 ultrasonic sensor and activate the main design. There we have two eye openings, which will allow the left and right transducers of the HC-SR04 to operate properly. I intend using black matte colored tape on the outer cylindrical sides of the transducers, so let's color them matte black by pressing A for appearance, using the keyword matte. Grab a matte black color, select faces, and color the transducers matte black. To continue, click here for part 17. If the link isn't showing, part 17 isn't quite ready, but should be soon. Check the description for my upload schedule. Thank you for watching.